Hello everyone, and thank you all for joining my session. I want to tell you a story today, a story about a young analyst working in a manufacturing company and his journey into the self-service BI world. My name is Cristian Angel and I will be your storyteller today. I'm a project manager turned into a data guy, a certified Microsoft trainer holding some other data-related certifications, working exclusively with data for the last 7-8 years, coincidentally in a manufacturing company, and the story you'll hear today is actually based on true facts, presented with real-life data, only anonymized a bit and simplified for demo purposes. So, there's this guy, let's call him Ben, working as a business analyst in an electronic manufacturing company, producing all kinds of electronic boards for different devices on different production lines, each of them with different production flows. As this is a true story, most of the units produced were good, but there were also some boards failing in different stations on the production line. By the way, these failing boards are called bone pile in manufacturing, and you'll hear the term a lot in my session today. And Ben wanted to know details about them so he can help improving the production rate. The entire production in such companies is tracked using different manufacturing execution system softwares, and all of them have some standard reports allowing exports to Excel. That was how the production was done in Ben's company, and the production supervisors were exporting on daily basis previous shift bone pile data to Excel, and using some filters they knew where to focus to reduce the bone pile. The small dataset sample you are seeing, it's actually a daily export that was supposed to be analyzed on daily basis, and it's only 82 rows. It contains the export date, the production date, the serial number for different product codes. We have several product codes in the list, the time when each of these serial numbers from each of the product codes went into a bone pile station, so it failed on a different station, the station and the IDs where those units failed, the unit price which was added afterwards for additional purposes, but we will not use it in the demo today, the aging days so that they can have an idea about how long is the unit still failed there and not repaired, the aging type, and a dimension inside the same data set with different aging types. It's under 5 days, it's a fresh failure, and of course there are some old ones that were supposed to be shipped meanwhile. Ben was thinking how can the situation be improved, and he had a proposal to eliminate the manual export of bone pile data. He talked to his IT friends to build an automatic job to export the data and insert it into an Excel template with some pivots already built, and every day the status of the bone pile came as an Excel file by email to the entire team. As time went by, and the number of boards produced grew bigger, and also the number of boards in bone pile went higher, a new way of tracking was needed. It was exactly the time when Ben discovered self-service BI in Excel with the Power tools like Power Query and PowerPivot. As these seemed to be the perfect tools to combine data from different files and get all kinds of insights with a single refresh click, our hero started to build a single file tracking all the bone pile data there. After a while, Power BI became a thing, and Ben wanted to take the report to the next level. He spoke again with his IT friends and managed to import daily bone pile data in a SQL database, building a simple Power BI report with interactive charts, and everyone was happy. All the data was collected and analyzed automatically. All the team members were using the report on daily basis, and the time spent working with exports and analyzing data decreased by 90%. The report you're seeing is Ben's report, and he teach me how he did it, and I will try to explain it to you. It is a very simple data model, a star schema with a single fact table and 4 dimensions. All of them are arranged in a Collie layout methodology, as Matt Ellington likes to say, with the fact table on the bottom and the dimensions on the top, simulating a waterfall for the filters coming from the lookup tables or the dimension tables to the data table or the fact table. The entire team loved the Power BI report, and I asked Ben, how did you do it? And he showed me. He said that he followed the 4 stages of self-service BI. First, getting the data using Power Query from a multitude, hundreds of data sources, and he used what he got in his hand, loading the data, only the necessary data, into the Power BI database, then modeling the data either in PowerPivot in Excel or Power BI, or you could model it in SQL analysis services, then visualizing the data, creating the reports and the dashboards and everything else, and then sharing securely the reports using the Power BI service. As the entire report is based on different daily snapshots, so bulks of hundreds of records, adding them together doesn't make sense, because what you have as a failure today can be different tomorrow. This is why when Ben built the measures to display in the Power BI report, he had to work with semi-additive measures, and I'll show you how the measure was built. So basically, Ben wanted to have in any moment, regardless of the level of calendar where he drills in, so either it's a day level or week level or month level or fiscal quarter level, he only needed the last data in the model. This is why in the measure he just built a variable max date, calculating all the time the latest date in the current filter context, building a table, adding a calculated table for each of the production weeks that he has in the calendar table, getting the last day for that production week, and then using treat as in the last date with lineage, using this variable in a calculate to get all the time the latest data in the model. In order to explain this better, let's focus on this matrix chart showing bone pile data by aging type, and we should focus on the 6 units at the ending of March under 5 days. Let's expand this and drill down one level from month to week level. If we go to March, we see that the 6 units are the ones that were visible in the last week of March. And if we go even one more level down and we go to March, we'll see that the 6 units that we were talking are in fact the ones that were visible in the last day of March, even if during that specific week we had different levels like 4, 6, 11, 8. So when Ben had his report done and working completely, he just put 4 charts showing data on the 4 dimensions that he built in the model: the aging type, the family name, the product codes, and the Bompile station where each unit failed. All of them are interactive, all of them are working completely, but he wanted to go one step further, and he wanted to build everything dynamically. So leveraging the field parameters, he built a new table, this one, with all the dimensions there, and everything, all the charts that he built before are just dynamic, showing everything by the selection, single selection in this slicer on the top. So if you want to see all the units failing by aging type in all the charts, you just push the aging type. If you want to see everything by Bompile station, both the weekly or monthly or whatever selection you are doing, everything is dynamic, or by family name. Well, we should take a look at this family name because we'll come back to it later. So everything is great. The Power BI report is working. It's having a SQL database as a source, Excel file for this demo, with snapshots of daily data showing correctly the numbers using this rather not so easy DAX formula to get always the latest day in the selected period. It has the entire history of snapshots from the beginning of 2022. It was even updated to leverage field parameters, and one of the guys in the team goes to Ben and says, "Hey Ben, could you modify the names of the stations in the report so that they appear like they are in the different report?" And Ben tells him, "Well, this is not really possible, as this is how the data is imported from the SQL database and we don't have access to it, even if he could do something in Power Query, but basically ignoring the change." And this is the first type of slowly changing dimension, the type 0, where the change itself is basically ignored. Then, after a while, another guy from the team notices that one of the product families had a name change from audio to audio devices, starting the beginning of the year, and asks Ben to talk to his IT friends and update the name in the database, overwriting the name with the new family name. And this in the data warehouse world is called a type 1 slowly changing dimension, where basically you are overwriting everything. After a while, the customer calls Ben and tells him, "We've had an internal change, and starting a certain date, we're regrouping some of the SKUs we're producing, creating a new product family called Computers General, and SKU ID 67 needs to be reported accordingly. We would like to see all the reports using the new family names." This type of change, where the primary key needs to remain the same but certain attributes of that dimension are changing over time, is a type 2 slowly changing dimension, and it can be solved by adding a new record. Adding a new record in the dimension table is not enough. As you see, yes, we are adding a new record, keeping the same ID, changing the family name for this one, but we also need to add 2 additional columns. One column with the start date, keeping the start date at the beginning of the data model or the beginning of the calendar, and putting an end date whenever that specific attribute is changing, like here. So if this product with ID 67 was laptops until the 31st of March, always when you are adding a new record, the next attribute, computer was a family name, needs to be added on the next day of the last day before. So this is starting to be placed in a different family from the 1st of April. There are some steps. I'll show you how, in general, how this is implemented in Power Query, and then we'll move to Power Query and show it how to do it exactly. First step in implementing a slowly changing dimension is add a start date and an end date to the dimension table. Then, depending on how much you want to work on it, you have to add a surrogate key to the dimension. First, you could do it with meaning, and I'll show you what I mean by this. But as we are talking about self-service BI, usually we are doing it with meaning because it's easier to debug afterwards. But in the data warehouse world, true data warehouse guy would tell you that the surrogate keys are without meaning. I'll tell you about the advantages and disadvantages for each of them. Then, after we have the surrogate key in the dimension table, we have to create a bridge query and then merge the surrogate key into the fact table. Let's move to Power Query and show you what I mean by this. Going back to the Power BI report and clicking on Transform Data, we are actually opening the Power Query editor, and if we press Ctrl+Shift+ to zoom in a bit, I'll walk you through on what we have here. Basically, we have three layers of queries in this data model, and I'm usually working like this because I'm applying the three-layer pulse methodology when we're working in Power Query. The first one is the raw data connection, where you have a single query for each data source not loaded into the data model. So its loading in the data model is disabled. From this raw data connection, we can spin a set of different staging queries, and now the data source is an Excel file, and we have different tables out of the raw data. And then the final layer, it's the data model layer, and I'll show you on a screen how this is done, because even if it's not mandatory, it's a good practice to work like this for different reasons. As I said, the first layer is the raw data connection, where you, for each data source, you are building a query and not load it into the data model. The second layer is the staging queries layer, where you can reference the initial query, the raw data query, and build your own staging tables. And the third layer is the data model layer, where you keep only what you need to load in the data model, and this is the only one where you enable load into the data model. This type of setup can help you in two main ways. One, to stay organized and have a clear data lineage when you are doing debug inside your data model. And two, this setup always fix the formula firewall errors that everybody found at a certain point when working in Power Query. Going back to the Power BI model, Let me show you the query dependencies here and explain what we have. We have the connection, the raw data connection to a file. I have a parameter changing the file, and I'll show you when I'm using it. We have the staging layer here with different queries. This is another advantage when you have staging layers, because you can reference different other dimensions or queries out of the initial query that you had. And this is the data model layer, the last one, with the data actually loaded in the data model. If we are checking the data model, you will see that we only have 5 tables: the BOM pile data with the fact table and the 4 dimensions, which were spinned off, some of them out of this BOM pile data that we have. Going back to the data set, let me show you the original data set when everything worked. This is the data set. We have the BOM pile data with different snapshots on different days. So in total 17,000 rows. We have a product list, the initial product list with the product ID, product code and the family name, and we had a fiscal calendar that Ben was using inside the report. The parameter inside Power Query here is actually allowing me to switch the source for this raw data. You see here, I'm getting the file name here, and I'm switching the source for the second data set that we have, the one with the slowly changing dimensions. If we go back to the second data set, let me show you the difference between this one and the original one. You'll see that I added a new row for ID 67, but with a different family name. And for the first one, I also added 2 additional columns with a start date and end date, putting a start date for all the products in the dimension. But for the one that we duplicated, I added an end date, and then the start date for the new family is the next day after the end date. Let me close this and go back to Power Query, change the data set to this one, slowly changing dimension, and try to load it. What do you think it will happen? As we know, in a dimension there cannot be two duplicate IDs. This is why we got this error. So the first thing that we should have done was to delete temporarily the relationship between products and BOM pile data. Refresh again. Let's save the report with a different name and go back to Power Query and do the slowly changing dimension. Now that we know that we have the correct data source, we'll go through the staging queries and refresh the preview for all of them. And let's focus on this query, the one that we have with the new ID. Ctrl Shift plus to zoom in. So on this one, yes, we have a start date for all the products, and we have an end date for the one that switch the family. First thing is to change the type for start and end date to dates, and we have to make sure that the end date is always fully populated. We have two options here: either go in the calendar table, find the latest date there and replace it here, or we can do it easier with a blank query, just adding the today date. So date time date, local now, date time local now. We're just getting the today date. If you see, the symbol is different because this is a scalar query. These are queries with the result as a table, but this one is a scalar table. Let's call it today, and let's try to fill here on the end date, replace the nulls, replace values with today. We cannot do it with today, but we can do it differently. Let's hardcode the date. Let's say the end of the year, 2022 12/31. Now we have an end date, but we can modify here in the formula bar. We can replace the hard-coded date with the query that we had here, just putting today. Everything worked. We are good to go. The next step in implementing a slowly changing dimension type 2 is to add the surrogate keys. And as I told you, there are two types of surrogate keys: the ones without a meaning, which are easier to implement but harder to debug, and the ones with meaning, which are a little bit harder to create but easier to debug, and usually they are fit in the self-service BI world. We'll do both of them, and we'll start with the ones without meaning. And for this, we had to add an index column from 1 with unique IDs from 1 to whatever number you have in the dimension. This will be the new key. Let's put link product ID. And then the next step would be to create the bridge table. And this is done by referencing staging products bridge. And here we keep only the necessary columns. So the product ID, the start date, the end date, and the link product ID. In order to know exactly on which day we had which product with the new link product ID, we will need to add a column listing all the dates between the start date and end date. And adding this column, it's pretty easy with a custom column. Creating a list, and here inside the list we will need to list the start date and the end date. But as lists don't work with dates as they are, we can do number dot from number from start date, dot number from end date. Here, for each of the product IDs, we got a list with dates as numbers where that specific product ID had the ID, and for 67, for example, the one that we've added, we have two sets of lists, and the next step here would be to keep only the product ID, the link product ID, and the newly created column. Remove everything else. And now, if we expand this list to rows, we will have a huge list of dates, one for each of this combination. So let's expand to new rows. Change the type to dates. And yes, depending on the number of items in a dimension, you might get potentially some performance issues, but if this is the only way to solve the problem, this is how we have to do it. The last step in implementing the slowly changing dimension is linking the product ID, the new product ID, inside the fact table. So going to the Bonepile data, go to home, merge queries, and here we have to merge with the bridge table based on two fields. One, the production date, selecting the date that we just expanded, keeping the control pressed, product ID with product ID. The order doesn't matter when we are doing the merge, as long as we are merging the right columns together. We don't care about much the type of join, we are just keeping it with the left outer join, and we see that we have matches for everything in the database. From the new column, we are expanding only the link product ID, the new one, unchecking the button with the use original columns as name as prefix, and we are getting the link product ID. Oh, we don't need the initial product ID anymore, so delete it. Close and load everything, refresh the data model. We already have the relationship done by PowerBI between the new product ID, the link product ID, and the new code inside the fact table. Let's hide this one and let's go back to the report. And now we have the new family as it was requested by the customer, with computers starting on April 1st. And Ben can go to the customer and says, well, we have the new report. Everything works as before, and the family name, we have the new family name here. Going back to Power Query to implement the surrogate key with meaning. This time we'll have to add an additional step at the beginning, sorting the primary key and the starting date before doing the next steps. First thing after sorting is group everything by the primary key, calling it all data, even if the name itself will not matter much, keeping all the rows for each of the IDs, and obtaining for each of the IDs a table with all the details for that specific IDs. And of course, for the ones that appear only once, we have only the start date and the end date. But for the ones that are appearing several times, we'll have 2, 3, or how many movements we had on that specific ID. The next step here is to add an index to this table, and this can be done using a custom column, and use table add index column. This table.addIndex column is requesting us a table as the first argument. This is the all data. A new column name, index. An initial value, which is 1, and an increment, which is also 1. Closing the parentheses, we'll get an additional column to this table, but this time we also have an index for each of the products inside that specific table, and for this one, for 67, we have an index of 1 and 2. These are the ones that we were talking with meaning. Now let's see how to implement it completely. We'll remove everything else and keep only this table, expand it completely, Ctrl A and detect data types. And now that we have an additional index column, we can create the new surrogate key with meaning by concatenating the product ID and the new index in an additional column. And let's do it. We can add a column, a custom column. Because we have IDs as numbers and the index also as numbers, we will need to use the text.from. Text.from IntelliSense. The product ID concatenated with a pad start. On text as a nullable text. It's the text out of the index. So, text from index. Count as number, we can put a 3, for example, at the beginning, and the character that we want to pad at the beginning will be 0. And the new column will be called link prod ID. And we have a new column with meaning. Well, maybe if we want to do it even prettier, we can modify it, and when we are doing the merge, we can also add here a dot. And now we have IDs with real meaning and easier to trace. From here on, the steps are more or less the same like the other ones. We need to create the bridge table. So let's create the bridge table by referencing the products. Bridge. First thing that I should have done on the previous example was to disable load on this one. From here, keep only the columns that we care about. So the product ID, the start date, the end date, and the new link product ID. From here, we should add the list of dates for each of the link product IDs here with a new column, custom column. We'll do a list on number from start date dot number from end date. Dot from getting the list of dates for each of them, and from here on, as I said, the steps are the same, keeping only the product ID, the link product ID, and the new created custom created column, removing everything else and expanding everything to new rows, setting everything to date. And then we have to do the last step, go to the fact table and merge the bridge table that we've had, the product ID with product ID, production date with custom. Keeping the default with left outer join, we only need the link product ID out of it, set it as a text or number. Make sure that in the product table we have the same type. Deleting this index as we don't need it anymore, and loading the data model. Let's check the data model. Yes, the relationship was done correctly between link product ID and link product ID. Hide the key in the fact table and everything works. Again, all the other buttons, everything, all the other dimensions are working correctly in the Power BI report, and this is how you can implement the slowly changing dimensions type 2. Closing thoughts from our friend Ben on what to remember when implementing slowly changing dimensions type 2. First of all, delete the relationship between the fact and dimension table that you are working on. Then make sure you have the two additional columns, so start date and end date, or from and to, and make sure the end date or the to is always filled up. It's up to you whether you are using a date from the actual calendar or you are using today. Create surrogate keys in the dimension table with or without meaning, depending on what you prefer. Create the bridge query with surrogate keys for every date, and don't forget to disable load on it. Replace foreign keys in the fact table with the newly created surrogate keys, and then recreate the relationships between the fact table and dimension table using the new keys created. Thank you all again for joining my session, and thank you Enterprise DNA for organizing this. I'm really honored to be part of this event, and I hope you'll find this session helpful in better understanding how to track historical changes using Power Query. I'm happy I was able to share a bit of my knowledge, and I encourage all of you to start sharing so others in the community can benefit. Feel free to connect with me on LinkedIn, follow me on Twitter, or subscribe on my YouTube channel. Thanks again. Bye everyone.